The last way we're going to analyze the data in this problem is to construct a frequency histogram. So a histogram is either a frequency or relative frequency bar graph. So your horizontal axis is your variable and your vertical axis is frequency or relative frequency. Now we're going to use classes or groupings here, which are going to be non-overlapping categories for our variable. And some general rule here about the number of classes. If you've got less than 25 observations, 5 to 6 classes, 25 to 50, 7 to 14 classes, and greater than 50 observations, 15 to 20. Well, we've got 64 observations, so we want to use in that 15 to 20 category. So the way you determine how wide your classes are is take your high minus your low and divide by the number of classes. So our highest data value is 15, the lowest was 1. We divide by 15, you get 0.93, which we round up to 1. So we're going to just group our data by one number at a time, so one number in a class. So here I've listed the classes from 1 to 15, and then our frequencies. If you count the number of 1s in the data set, you'll get 3. The number of 2s, you'll get 0. Number of 3s, you'll get 3, and so on. Now, if you add up those frequencies, you'll have 64 total. So to get your relative frequency, you'll take the frequency column and divide by 64. And that will give you 0.05. And then 0 divided by 64 is 0, and so on, dividing by 64 all the way down. If you sum these up, you get 1.00. Now, because of round off, you may get 0.99 or 1.01. So here's our frequency and relative frequency histograms. We've got the improvement score along the horizontal axis. And actually, the way that these bars are drawn, we want to shift our x-axis over a little bit because this is the bar for 1. So 1 should actually be centered on that bar. So we would actually like our horizontal axis to be right there. So this is the bar for 5, 4, 3. There's no bar for 2, the bar for 1, and no bar for 0. So the bar for 1, we've got a frequency of 3. So this is height 3 right here. No bar for 2, height 0. 3 and 4 both have height 3. 3 and 4, height 3. Bar at 5 has height 4. It says frequency 4, and so on. And you see we have same general shape that we had with the dot plot above. We've got 2 areas of concentration here. Relative frequency, same thing here. We've got 1 bar for each value, and this should be shifted to the right just a little bit. There we go. So the difference here is that relative frequency is percentage. So our highest relative frequency was a 0.17. And so I stopped my scaling here at 0.15, and our highest bar is a little bit higher than that. So notice same general shape in the data here. And we can recover all of the data values also from our frequency distribution. Now, if we want to group it a little bit tighter and have less classes than we do, we can do that. This is more of an art than it is a exact science here. So let's say that we grouped in classes of 1 to 2, 3 to 4, 5 to 6, etc., down to 15 to 16. So this frequency of 3 is saying there's 3 that are either 1s or 2s. But we don't know which one they are. We just know there's 3 total. There are 6 values that were 3s and 4s. And we can see that going back up above. 3s and 4s, we had 6 total. 1s and 2s, we've got 3 total. 5s and 6s, we've got 13 total. 3, 6, 13, etc. So that's how we're getting those values. And then our relative frequency, well, our frequencies add up to 64. And so to get these relative frequencies, we again just divide everything by 64. And then here's our graphs over here. And again, these would need to be shifted. I am actually going to take those numbers off there. I'm going to label them a little bit differently. Now, generally what you would do is you would label this first bar, put a tick mark in the middle of it, and label that bar 1-2. And then a tick mark in the middle of the second bar, label that one 3-4, and etc. down to the last one, which is your 15 to 16. So now if you've got, this is discrete data, 1, 2, 3, 4 with spaces in between. There's no 1.5, no decimals. Now if you had a range of values like 0 to 2, you'd put 0 on the left side of the bar and 2 on the right side of the bar. That would be common practice. For relative frequencies, our relative frequency went up to a little less than 0.2, well actually a little greater than 0.25. We had 0.27 at the highest. This bar should go up a little higher than our 0.25 here. So something like that. Notice, again, same general shape here from left to right. It's just that we're looking at proportion on the vertical instead of raw number. Now note here that we lose our individual measurements. We can't recover the individual data values here once we start grouping the data. We can do the same interpretation that we did with the dot plots, center, outliers, symmetry, spread. Notice here it's harder to identify possible outliers because by grouping we've gotten rid of gaps that were there before. Now you can also graph these histograms, a little bit of work, but you can also graph these on the TI-84. The TI-84 steps for histogram are the following. You will enter your data into list 1. So it'll be one list for all of the data. You go to second y equal to get your stat plot. You press 1 to access stat plot 1, set the cursor to on, select your histogram icon, make sure list is set to L1, and then zoom stat is going to give you a nice window, and then press graph and it'll show your data. So I've already entered that data in. Let's take a look at it here. So here, here we have the calculator. You go to stat and then edit, which is enter. I've already entered the data in here. You now want to do second y equals. So this is stat plot menu. Notice first stat plot is off. So press enter. And then on is highlighted. Well, it's blinking. Press enter there. And now the on is blinking. So I arrow down one and I want to go across. Right here is our histogram. So I'm going to arrow across there, press enter, and I make sure that my X list is list 1. Frequency of each value is 1. Now I'm going to go to the zoom menu and I'm going to press 9, which is zoom stat, and there is our histogram. So I guess I actually didn't have to press the graph button. And you can see that that does look pretty close to our histogram here. Scaling is just slightly different. So scale vertical here is in 1s. So that's a histogram on the TI-84.